experienced Python developer, DevOps engineer, and cloud automation engineer. Um, Let me tell you a little bit about myself. Who am I? I have 30 years professional experience. I have a bachelor's degree in computer science and engineering from Northern Arizona University, graduate certificate in data science foundations from North Carolina State University. I'm an expert level in Python development. I've been doing it about 12 years. Good experience with front end development using JavaScript, React, Angular, and Vue, charts, etc. Great experience with monitoring and observability using tools like Splunk and Grafana. And very good experience with ETL processing, like grabbing stuff from various web sources, um, uh, putting them in a database, and doing some ETL transformation on them using maybe a tool like Spark or Glue or various other things, or just straight Python to do that type of processing. Uh, why choose me? I have experience. I have ability to adopt the proper technology or problem because I've seen a lot of problems over the course of my career, and I have the ability to right size it for you. Not too complicated, not too fancy, but fancy enough so it gets the job done. So you can you can use it. It'll be usable for you. Quality at this stage of my career, I've perfected or I've honed my craft to the point where it's I've honed it to a high degree. So there'll be a section in here about the development tool chain. You can see I use a lot of automation to ensure high quality code, affordable. So even though I have lots of industry experience, I'm new to freelancing, and I very much want to price myself into where I can win a bid for you, and that you'll be happy with the price. I'm not going to overcharge you. I'm going to give you a good price and good quality work. Um, this is a I want to do a quick example of an application I wrote just as a sample of what you might be getting. It's not overly complex, but it demonstrates my approach to designing and implementing code. So here it is as a YouTube channel recommender. What you can do is give it a search string, and it'll go off based on various criteria. It's going to recommend YouTube channels for you to subscribe to, not just videos, but channels. So how does it do it? It looks at the number of subscribers the channel has, number of videos the channel has, the relevance of the channel based on the or description. So it's going to look at the description of the channel and your search string. It's going to figure out how similar those two things are. It's going to look at the number of positive comments in videos. So you don't want a channel with all negative comments on their videos, right? I don't know what could be going on. It could be the video quality, audio. It could just be videos that people don't like, right? So you don't want any of those. You want high quality videos in your channel. Okay, here's the user interface. The search criteria entered here was Grateful Dead, and it comes up with a lot of relevant channels to subscribe to. Also gives you a breakdown, like a visualization of different factors that went into determining these recommendations. So you can look at the number of videos, the number of subscribers. You can see who's ranked the highest in each one of those. The sentiment, which is the number of positive comments, and the relevance, which is the similarity between your description or your search string and the description in the of the channel. Okay, basic architecture. It's two Docker containers. It's got a front end container that uses Vue, JavaScript, and Node. It's got a back end container that uses Fast API, Natural Language Toolkit, and Python. It talks via the YouTube public data API. So it does things like search for videos. It looks at comment threads, and it looks at channels. It uses Docker Compose to build and deploy the two containers, so you don't have to do too much besides a Docker build and a Docker Compose up, and you'll have both containers up and running without any kind of issues. You just connect your browser to the front end container, and all the other work is done for you. Okay, so this basic type of structure, the way it was set up with a front end and a back end and um, a model, basically to look at the data, which is what the Google API is doing for us, um, is based on something called the model view controller. The reason that's nice is you can vary the front end. the back end is separated, so you can do things like develop tools that use the back end without using the front end. You could develop a whole new front end. Um, and it isolates the business logic in the controller from that. So all that, a lot of the complexity is pushed down and the front end to the controller, and the front end just concentrates on the view, which is good at. You don't want to be mixing a lot of complicated processing logic in your JavaScript code. You could do it, you could do whatever you want, but this is a nicer way of doing it. And then your model down here, usually, typically that's a database that the model view controller is talking about, but in this case, it's the actual API. So that's what's controlling the access to our data, is going through the API. Okay, within our controller itself, we use something called extract, transform, and load. So the code is structured that way. You'll see methods that do extraction, methods that do transformation, and methods that do load. Why this is nice and good for your code is you can vary those things. You could say multi-process a particular piece of that, and without affecting the rest of it, right? So that you can multi-process that and get the benefits of parallelization. You could do algorithmic things to reduce the number of API calls, right? So you can put clever logic in there to reduce the number of API calls without affecting the rest of your, your transform code. It'll be easier to do that because of the way it's structured. Transform does things like it adds the sentiment analysis and the similarity scores in there. Does things like that. It's stuff that's not part of the raw data you get from YouTube. You derive those things and you add. It's like your value added to that. And the load is typically where you load to a database, but here we're just writing back via the REST API. Okay, development tool chain. I think this is very important. This is something that, over time, over as a Python developer, I've really, I've used these tools, and these tools help me a lot, and I believe they could help, with a quality product for you. You'll get all these, all this stuff basically is part of the bargain, right? So I use static code analysis using Flake 8. So that's like a typical linter, right? It's going to find problems with your code before you deploy them, like unassigned variables and different things like that. It'll avoid those big stack traces. Type checking, I'm a big fan of type hints. So basically, my Python's got type hints on everything that's all the parameters passed in and the return values, and MyPy is going to check those. So it's going to make sure that you don't pass a string to something that's requiring a list or a different type of object. All that stuff's going to be correct. Code formatting. So long ago, I gave up like trying to have custom formatting of my code because I like the way certain things looked. I just use Pep8. So we use black and Pep8. It formats all the code the same way. Everything's going to look the same. Everything's going to look nice and pretty using black. Import sorting. There's various types of problem that can happen when you use Python imports. Weird problems that are really hard to find. So it's nice to have this import isort that'll take in sort your imports in a way that according to the Python specification. And it really decreases the number of those type of problems you get. And also heavy unit tests. So I'm going to unit test, my target is always 80% or above coverage. So all my code I'm going to deliver, I want to have 80% or above coverage. Now that's negotiable. If you don't want as many tests and you're more worried about the deadline, that's okay. But I really look forward toward that. So I want to unit test my code, and I want to give you a coverage report that this is what I'm doing. Also, the stack that I use with Fast API, it has Swagger documentation built in. So when you document your code with doc strings, it'll automatically generate Swagger for you, so you can look at the API and use that to develop other tools or different things like that. Also use a tool called pdoc, which will take the NumPy formatted doc strings and generate a nice website for you potentially if you want, or you can just look at the code, use it as a tool to browse your code. Some examples. So The tool chain I have is run as a GitHub action. So when you push code to your main branch, or you do a pull request, say you're doing a bug fix, you create a separate branch and you do a pull request back into main, it's going to run all these tools in the tool chain for you. So it won't let you deploy your code until these things pass, right? That's what's going to happen. These things are going to fail if they're not if 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 there's an issue, there's a failed test, there's a isort formatting problem. You're going to have to go back and format the code locally, redeploy it, and get these to pass. So any code that I deliver, all these things are going to pass. All the tests are going to pass. It's going to be black formatted. It's going to be, the linter is going to be clean. So everything like that is going to be done. Okay, also run as a pre-commit hook, so I can run these things locally to work on problems, or when you commit the code, it's going to run the same formatter and everything like that. So when you go back and do your push to main, you shouldn't have any problems because you've already run these same tools during the commit phase. So you can see here with the coverage report that comes out and all the different tools that are run. Also documentation generation. Like I said, fast API allows Swagger or generation, so you can use this the API to your endpoint /docs, and it's going to show you the documentation for your backend API. You can see there I use Pydantic, so all these things are documented, all the different fields within the response and the query. So you can see all that. You can see your query. You can see what you should be getting back in your response. If you want, you could do a REST. You could do a REST API to that and use this data yourself and develop your own front end. You could develop tools, automation tools for that use that data, etc. You don't need, you can use that like that. You got good documentation for it. Also, like I said, pdoc right here. So you run the simple command pdoc -d numpy, because I use numpy formatted doc strings, and point in at the source. And you're going to get a nice description of every method, every class in the code. And you're going to be able to see all the different parameters that are passed, what types they are, and a description of each. So you'll have nicely documented code that's easy to browse, easy to figure out, easy to modify. And that's what I aim for. Wrapping everything up, good luck. Whether we work together or not, I wish you the best of luck finding an outstanding freelance developer to fill your needs. And I'm available anytime you may need me. And I look forward to working with you. Thank you very much.